Welcome to Philosophy on the Fringes, a podcast that explores the philosophical dimensions of the strange and the mundane. We're your hosts, Megan Fritz
and Frank Cabrera.
On today's episode, we're returning to the topic of extraterrestrial life, this time focusing on the Fermi Paradox. According to plausible assumptions, we should expect many advanced alien civilizations to exist in our galaxy. But where are they? Welcome back to Philosophy on the Fringes. Thanks for joining us for episode 8, where we're kind of unexpectedly doing a follow-up episode to our episode 6, which was on extraterrestrial life. As we mentioned at the end of our last episode, episode 7, after our episode on aliens, we kind of got a bunch of, I don't want to call it fan mail, complaints, I guess, from kindly worded complaints from listeners who were saying, hey, I'm really excited that you guys did this topic, but you forgot or neglected to cover this really important other topic that I really wish you would have covered. And several people wrote in to name different things that we should have covered, and we agree that we should have covered these things. And so that's what we're doing today. We're going to cover them.
There's a lot to talk about, so we're going to rectify some of those missed topics in this episode.
And those topics, not all of them, but a large amount of them were about, or at least tangentially related to, something called the Fermi Paradox. So Frank, do you want to start us out by just kind of introducing us to the Fermi Paradox, what it is?
Yeah, the Fermi Paradox is one of these really important questions that is often raised in discussions of extraterrestrial intelligence and the search for extraterrestrial intelligence. So it derives from the Italian physicist Enrico Fermi, who, in a discussion with some colleagues about UFOs in 1950, asked the really poignant, simple question, where is everybody? So we have some good reason to think, based on some of the kind of statistical arguments that we talked about in our last episode, that there should be intelligent life somewhere else in the galaxy. But we haven't really detected any of this. There's no credible reports of extraterrestrials on Earth or in the solar system. So what's the deal? They should be here, but we haven't detected them yet. So this problem gets a lot of currency from the fact that the Earth is 4.6 billion years old, but it's not the oldest terrestrial planet in the galaxy. So according to scientists, the best estimates are that the median age of terrestrial planets like Earth is 6.5 billion years. And in fact, some of the earliest terrestrial planets are 9 billion years old. So as it stands, Earth is a latecomer in the galaxy. There are terrestrial planets out there, many of them, that are billions of years older. So that gives the aliens a lot of time to evolve into intelligent life, a lot of time to come up with an advanced civilization. And even if they only have technology that allows them to go at, say, 1% the speed of light, well, the galaxy is 100,000 light years across. That would only take 10 million years for them to get here, to colonize the whole galaxy from end to end. That's a long time, but recall, right, 2 billion years. They've had 2 billion years to do this.
2 billion extra years than we've had.
Over us. So the question is, where are they? Why haven't they colonized the galaxy yet? Why don't we see any credible evidence of extraterrestrials? Everything just seems so quiet in the galaxy, and that's the question. That's the paradox. Where is everybody?
Now, Frank, we're recording this at kind of a fortunate time to be talking about this topic again, because it might seem, at least to some, like the answer to the Fermi paradox is there is no paradox. They have actually arrived, right?
Yeah, that's right. So this is one potential solution to the Fermi paradox. They're already here, right? They've already visited Earth. But I guess people who still think this is a paradox don't think that kind of solution is good enough, that the reports aren't credible enough. Or at the very least, we should see more evidence of aliens.
Right. So speaking of reports and of seemingly credible reports, though, 4 days ago, we have this guy, David Grush. He's a veteran. He's a former member of the National Geospatial Intelligence Agency and a former member of the, I guess, what used to be called the UAP task force. It has some new name now. a report came out that he came forward as a self-proclaimed whistleblower for this UAP task force, which has a different name now. But a whistleblower for this task force saying, hey, actually, here's what I've learned in my tenure at the task force. The United States government has loads of aerial spacecraft of non-human origins, that they know is of non-human origins, that they know came from somewhere other than Earth, and they've been kind of keeping it and hoarding it and trying to reverse engineer it for decades and decades and haven't come out and told the public yet, which he's alleging is illegal. And so that's kind of what everyone has been talking about lately.
Yeah, so you tweeted about this. A lot of people were skeptical, though, right?
Everyone was skeptical.
What did they say?
Well, everyone was skeptical, and they were like so skeptical. And I guess, obviously, I get going into a situation with, a healthy amount of skepticism. But this guy is like a decorated Air Force veteran. He has an immaculate track record at the UAP task force. And he even, in his report, quotes another former member under an alias, but another former member of the task force, confirming the exact same thing. I don't know if people are trying to get in contact with him. But yeah, I guess I was a little bit surprised by the extent of the skepticism. Like, this guy must be lying, or stupid, or just trying to get attention, or, a popular apologetic was, oh, this is a diversion technique, or whatever.
Right, the government's lying about their lying.
Yeah, although notably, as of 2 days ago, the Pentagon did come out and deny everything in Grush's report.
Yeah, so I'm not sure what to make of that. I guess my thought is that I think we should take this a little more seriously than maybe some of your Twitter responders are saying. But yeah, I don't know. Yeah.
People are comparing his report, whether favorably or non-favorably, to the report in, I believe, the 60s from Bob Lazar. It's a pretty famous case of someone also in a high-up position in the government. I think Lazar was in the CIA, something like that. I think he was in the CIA. Who came out and basically said the exact same thing that Grush said, that we have all of these non-terrestrial spacecraft that the world governments have been keeping and trying to reverse engineer for decades. And so some people are saying, oh, he's just resurrecting Lazar's conspiracy theory. But of course, if all this were actually going on, one would expect the reports to match.
Right. So the fact that it's similar to what some other guys said in the past doesn't debunk the current testimony, right? Because that it's real hypothesis would also explain that there'd be multiple whistleblowers. Right?
Yeah. So I guess it's just unhelpful.
Yeah, I don't know. So maybe that solves the Fermi paradox. I think people who think it's a paradox, though, still aren't going to be convinced that this is a solution, though, right? We need better evidence than just that.
There may still be a paradox, as you were telling. I guess we'll get into that. But there may still be a paradox even if we do have like one or two non-terrestrial spacecraft.
Right. So I should say what I've been reading in preparation for this. So I've gotten really into the Fermi paradox. I think it's a really cool problem. Not much written about it in philosophy, and really not that much written about it in a kind of academic settings. You'll often find astronomers in their popular books mention the Fermi paradox. Carl Sagan would mention the Fermi paradox in his video series The Cosmos. But I don't think it's taken too seriously as a scientific or philosophical question. And one astronomer / philosopher, Milan Ćirković, who wrote a book published with Oxford University Press in 2018 called The Great Silence, the science and philosophy of Fermi's paradox, he wants to kind of argue that this is something that should really disturb us, that we should really take this seriously, that this is, in his words, the most complex multidisciplinary problem in contemporary science. And in his view, part of the failure to solve the Fermi paradox is methodological and philosophical, that we're not really thinking about the question correctly. So in the book, Ćirković goes through something like 37 potential solutions to the Fermi paradox. So there's a lot of answers to the question, where is everybody out there? Or why is it so quiet in our galaxy? So Megan, there was a couple days ago, where I read through all the solutions to you. Do you remember which ones were your favorite?
Yeah, I mean, a lot of them were pretty similar to other ones, but the ones that, I guess the sort of solution that I really liked, that I have, I guess, always kind of thought was plausible and like a confusing aspect of these programs like SETI and such, is this solution to the paradox that's roughly, maybe we just like don't know what we're looking at or what we're looking for. Like maybe all these things that, I don't know, we look out into deep space, which we're able to do now, and we can identify things like exoplanets and moons and stuff. But like maybe that's not what they are. Maybe that's actually alien tech that looks like exoplanets or moons or behaves the same way, because why not? They're 2 billion years more advanced than us. Why think that it has to be some kind of like kitschy looking Star Wars-esque type thing? Like maybe we just have no idea what to look for, and so we go out into these, endeavors with cartoonish ideas of what we expect to find or what we hope to find. And, maybe we could find what we're looking for if we have the right expectations, but it might be almost impossible to have the right expectations.
Yeah, this is an interesting one. The idea that, so this is a little bit different from the standard UFO explanation. So Ćirković calls this the Fermi's flying saucer explanation. All those reports of abductions and flying saucers in the sky are credible, and that explains the paradox. So the thing that Megan's talking about is a little bit different than that. Maybe an alien intelligence is all around us, right? And like we just don't have a good grasp of what cognition is, and so we miss it. So this is an interesting idea. This is something that some scientists have toyed with. So the scientist Fred Hoyle, who's most famous for being an opponent of the Big Bang theory, he had a different theory of the origin of the universe. He once toyed with this idea. He thought maybe there's a higher intelligence that's all around us, and because it's so unrecognizable, we just miss it.
Did he propose the Little Bang theory?
No, he proposed what was called the steady state model. Where
there were no bangs.
No bangs. He actually coined the term Big Bang, but as a pejorative. I guess it just stuck. Mm-hmm. So, unfortunately, he's most famous for being wrong, I guess.
I like the bang.
Yeah. Okay, so that's one solution, right? The alien intelligence is here. It's just in some unrecognizable form. Maybe it's indistinguishable from the environment itself. Maybe the atoms in the universe and the laws of nature are in some sense are like an alien intelligence, some higher intelligence or something like that.
This makes sense to me because space is beautiful, and like our satellites and rocket ships and stuff are not. Yeah. So like if we were advanced enough to make them blend in, we should, obviously. There's like an aesthetic duty to do that.
Yeah, I mean, that's the best way of... So, we always try to overcome the environment with technology, try to control things. But maybe the best way to do that is to merge with the environment, right? The higher intelligence, its solution for dealing with the obstacles posed by the environment is to become one with the environment.
No resistance.
Yeah. So that's one solution that Ćirković talks about. He's somewhat favorable to that. He gives a letter grade to all 37 solutions. I think he gives that one like a B- or something like that. So he's pretty open to that one. He gives the Fermi's flying saucer solution, the proposal that the alien abduction reports are genuine, right? People are seeing flying saucers in the sky. He gives that an F. So he's not open to that one. He thinks the reports are just not credible enough to count that as a solution to the Fermi's paradox. But notably, right, this book was written in 2018 before these reports from people within the government and these intelligence agencies started coming out. So it'd be interesting to ask him whether he would give that Fermi's flying saucer solution a grade higher than an F.
It needs a significant grade increase to meet more than one letter grade. So Frank, Ćirković divides these solutions into all 37 solutions into 7 main categories.
So it's fewer than that.
Is it fewer?
Yeah, so one of the helpful things that he does in this book is not just go through a bunch of solutions. There are other books out there that do this. In fact, there's one book that goes through 75 solutions to the Fermi paradox. One helpful thing that he does, though, is he shows that a lot of these solutions can be categorized into 4 categorizations. So he has 4 of them.
4.
And these 4 categorizations are determined by the rejection of a certain assumption that gets the problem going. So that's one reason why I really like this book, is it imposes a lot of order on this problem. That he says, look, a lot of these solutions, they are similar in kind, and a lot of them, they form a natural class, and that class is tethered to a particular assumption that is denied by the solution. So first, I guess we should start off with what are the philosophical assumptions that he thinks generates this problem. So the first of these assumptions is what he calls realism. So this is the simple idea that we should basically trust our senses. Right? In his words, the best results in most cases happen by following empirical evidence and interpreting in the most direct and simple manner like what we see. So generally speaking, the properties that we observe through our scientific methods are, for the most part, perceived correctly, and they obey the laws of physics as we know them. So of course, right, there are weird things out there. Sometimes our senses are misleading. A lot of new discoveries in fundamental physics seem to challenge our common sense way of seeing the world. That's all true, right? But he says, for the most part, we should trust our senses. We get things roughly right. We're not radically deceived about the way things are. The second assumption is an assumption of methodological naturalism. That's the idea that's very common, that we have to prohibit invoking supernatural agents in our scientific explanations of things, which is not to say there are no supernatural agents, but just that you can't invoke them in scientific inquiry for our scientific explanations. That's the second assumption. The third one is a little more complicated. It's this idea that he calls Copernicanism. The basic gist of this is that we're average. So think about what Copernicus said about the Earth. He dethroned the Earth. The Earth is no longer the center of the universe. It's no longer the center of the solar system. It's just one planet among
It used
many.
to be, but he kicked it out.
Yeah, he kicked it out, right? He demeaned the Earth. So Copernicanism in cosmology extends this idea. In Ćirković's words, there's nothing special about Earth, the solar system, or our galaxy within large sets of similar objects throughout the universe. There's nothing special about us as observers, our temporal or spatial location, or our location in other abstract spaces of physical parameters, chemical parameters, biological parameters, and so on. That's all typical. Hence, our observations, including the results of all our sciences, are typical as well. So here's like a kind of analogy here. I suppose you pluck some guy randomly from the United States population, and then you wonder about what his income is. You probably shouldn't think that he's like a billionaire, right? You just plucked him randomly from the population. For all you know, he's just an average member of the population. So you should think he should have like kind of an average income, not something on one of the extremes. So too, right? If it's raining outside your home, you should think that it's not just raining outside your home, it's also probably raining in your town as well, right? Why think your home is special? The rain cloud isn't probably just over your home. So that's where this Copernican principle is coming from. It's this idea that we're not special, we're just average. So we sort of mentioned this in the previous episode, right? The first part of the Copernican revolution led to philosophers and scientists speculating more about life on other planets. So here we just take this principle and apply it even further. Nothing special about life on Earth, right? Life can evolve in other places. Intelligence can evolve in other places. Advanced civilization can evolve in other places. Nothing special about the Earth. The next assumption is what he calls gradualism. The basic idea here is that we shouldn't posit random catastrophes to explain the evolution of life in the universe. That we should think of the present forces as being the key to the past. Right? There's no special era in which things were really, really different. No special cataclysmic era. So that's a thing he calls gradualism. Right? No large discontinuities in the evolution of life in the universe. And then the last assumption that he uses to kind of demarcate the space of possible solutions is like a hodgepodge of economic assumptions. The basic idea here is that it would be feasible, practical, desirable for other civilizations in our galaxy to either colonize it or to make their presence known through their astro-engineering projects, large space stations, contraptions around stars to harvest the star's energy. Given a lot of time, we should expect civilizations to do this. They have an incentive to do it. They have all the reason to do it. And so we should expect that there is evidence of this. We should expect detection of their projects or presence. So those are the main philosophical assumptions that he puts forward that he uses to categorize things.
Remind me so can we just go through all of them really quickly?
Yeah. So we have realism, right? In a slogan, it says, trust your senses, more or less. Naturalism, no invoking God in explaining this paradox. Copernicanism, we are average. Gradualism, right? No massive catastrophes that wiped everyone out before us. And then finally, the last one is just what he calls a bunch of economic assumptions, right? It would be feasible, practical, desirable for them to colonize the galaxy or make large objects that we could see, that sort of thing. So those are the 5.
I guess I find a lot of these assumptions a little bit questionable, especially the first one.
Yeah.
I mean, I guess my preferred solution to the paradox sort of maybe like rules out this first one. Why should we think we should trust what we can see? Why we need to have an idea of what we're looking for in order to detect it when we're out looking for it.
Yeah, right. So I should note, right, it seems like you're going to have to deny one of these assumptions, right? So it's not as though he's saying, hey, our solution to the Fermi paradox needs to respect all of these.
Right, solving the paradox means that one of these things isn't true.
That's why he thinks it's really, really interesting, and why I do too, that the Fermi paradox seems to challenge an assumption that we are inclined to make, like in everyday life and in science, right? More specifically, that you have to give up something, which makes it pretty interesting.
So it's only like loosely a paradox. It's more like the Fermi really hard problem.
Well, you can think of every paradox as kind of like that. That's how I think of philosophers want to solve paradoxes, right?
Mm-hmm. Yeah.
Right. So if you deny realism, right, the simple idea that our senses are mostly right, then you have what Ćirković calls a solipsistic solution. So this is solipsism kind of. It's not exactly solipsism. It's sort of inspired by solipsism, right? Solipsism is that philosophical idea that everything in the world, including other people, is a projection of your own mind. So that's not what he means here. He just means that if you accept one of these solutions, a solipsistic solution, then reality is quite different from what it appears. You can accept some solution according to which reality is much different than it appears in order to solve the Fermi paradox. So the flying saucer solution would be a solipsistic solution because it doesn't really seem like the aliens are here, but according to the solution they are. We're just sort of missing it. Or the idea that we live in a cosmic zoo. This is another popular solution to this paradox.
You brought this up in the last episode, I think.
Yeah, we mentioned that in the last episode, that maybe the Earth is a zoo or a wilderness preserve, and all the other civilizations of the galaxy all have made a pact to not interfere with what goes on Earth. That's another solipsistic solution, right? Why? Well, it doesn't really seem like we're in a zoo, right? Where's the evidence of their presence? It's not enough for them to just quarantine us. They also have to hide from us too. They have to hide their macro engineering projects. The idea that we live in a computer simulation, that's another one that he considers as a potential solution to the Fermi paradox. And maybe there aren't any aliens because we're just in a computer simulation and the simulators decided not to simulate any aliens. That would potentially solve the problem, but again, reality would have to be a lot different than it appears.
That's all pop science writers' favorite solution to the Fermi paradox.
So what else? So if you deny naturalism, or then you have a supernaturalistic explanation. The explanation is there are no aliens because God only likes humans and only created humans. That's one answer to the problem. So speaking of which, I'm surprised that philosophers of religion have not pursued this sort of thing, right? We can have an argument for the existence of God as a resolution of the Fermi paradox. Somebody out there, you have a paper topic right now.
I know a lot of our listeners do philosophy of religion. Yeah. We are handing you this paper topic.
Handing you this.
Someone write it.
I mean, obviously it's related to kind of design arguments, like, well, God's the best explanation of the life permittingness of the universe. But the Fermi paradox adds an extra ripple to this. It's the best explanation of the life permittingness of like Earth and the absence of aliens.
And the apparent life hostility of the rest of the universe.
Yeah.
All we ask for is like a brief footnote.
Yeah, somebody write this, just give us a little footnote. And it's like, yeah. So that's another solution. If you deny Copernicanism, then you accept a rare Earth hypothesis explanation. We talked a lot about these in the last episode. I guess this is my favorite solution to this. I guess I think maybe life and intelligent life is not as common in the universe as the Copernican principle would suggest. Maybe intelligence is not as common in the universe as the Copernican principle would suggest. I think maybe intelligence isn't really that great. We have to remember that intelligence is an adaptation, and maybe it is only an adaptation here, right? What's so great about intelligence? I mean, it hasn't evolved that much on Earth. We're the only intelligent species as far as we know. I guess dolphins are smart and octopuses are smart, but not as smart as us. So intelligence hasn't evolved that much. Wings have evolved a lot. Eyes have evolved a lot. Exoskeletons. Those are really useful things. The form of a crab. Trees. Those are things that have evolved in various lineages. But intelligence hasn't evolved that much. So maybe it's really not as adaptive as it seems. Maybe intelligence is really rare because it's just not that great to begin with. So I kind of like that one. It kind of makes us humble, keeps us humble.
There's all those things that always go around Twitter that are, it's like some like fake data, and it's like, look, women really aren't attracted to smart men. Well, maybe this explains why.
Yeah, maybe because they're super annoying or something. I don't know. So if you deny Copernicanism, you got a rare Earth hypothesis. If you deny gradualism, that idea that there aren't like massive cataclysms that explain the evolution of life in the universe, then you have a catastrophist explanation.
That sounds like a crazy assumption to me, because there's so many catastrophes that happen in the universe, and like we already know that our Earth has been hit with asteroids.
Yeah, so he said, yeah, exactly. And Ćirković is solely aware of this. He says this is really not that great of an assumption to make in cosmology. This was a really important assumption in 19th century geology. Right? So this is where this term comes from. In 19th century, there are some people, inspired by theological beliefs that the Earth got the way it is through like a massive period of catastrophes, a great flood. Those guys were called Neptunists. Some people thought it was...
Why were they called Neptunists?
Because Neptune's the god of water. Yeah. And then the Neptunists contended with the Vulcanists, who thought that the Earth got to be the way it is through fire.
You saved that one for recording, because you had not said that before.
Yeah. Neptunism versus volcanism, right? An old scientific debate. So these guys contended with the gradualists or the uniformitarians, represented by Charles Lyell and James Hutton. And they thought, the Earth's features, it changed over a long period of time through like processes with which we're already familiar. Erosion, that sort of thing. So yeah, as Megan mentioned, right, so this is kind of a weird debate. Like it seems like a false dichotomy, because certainly cataclysmic events have affected the shape of the Earth.
Right? Ice ages, super volcanoes.
Yes,
I could go on.
Of course. Right. So I guess the question is like, which thing is more responsible? These slow processes with which we're already familiar that are acting in the present, or these cataclysmic ones? I guess that was the debate. But as Ćirković mentions, there's, a lot of cataclysmic debates, or a lot of cataclysmic events in cosmology. The Big Bang, right? The moon was formed by a cosmic bombardment, mass extinction events. So maybe gradualism isn't that safe an assumption. Maybe some giant gamma ray burst, right? Like burst of high energy electromagnetism, like wiped out all the life in the galaxy or something like that. Maybe some cataclysm we're not familiar with did that. That's another solution you can have. Some kind of cataclysm wiped everything out. And we are the most advanced civilization right now because all the other ones got wiped out before us. We're the ones leading the charge in terms of colonizing the galaxy. If you deny that view, you have a catastrophist explanation. And then finally, if you deny one of those economic assumptions, or you have what he calls a logistic explanation, that maybe the aliens just don't want to come here for various reasons. Maybe they don't like stars like ours. They don't like sun-like stars.
They're fiscal conservatives.
Yeah, it's not useful to colonize the galaxy or something. That's another kind of class of solutions. So yeah, I've been doing a lot of talking. Thoughts here, Megan?
Yeah, so I remember reading... I haven't read this book, but I've read about this book. It is a science fiction novel written in 2008 by a Chinese scientific sci-fi writer named, I don't know how to pronounce the last name, something like Sushin. And his novel was called The Dark Forest. And it basically offers a kind of response to the Fermi Paradox called Dark Forest theory. And the Dark Forest theory has 3 axioms, I guess. I'll read them off to you. So the first one is, suppose a vast number of civilizations distributed throughout the universe on the order of the number of observable stars, lots and lots of them. They call the study of these civilizations cosmic sociology. This is based on the Drake equation for habitable civilizations, number of habitable civilizations. Second axiom is, suppose that survival is the primary need of a civilization. And the third axiom is, suppose that civilizations continuously expand over time, but the total matter in the universe remains constant. So the book, in novel form, argues that the logical conclusion from the acceptance of these axioms is that any intelligent life in the universe is going to be like, not at war, but like they're going to be like enemies or like against one another in the struggle for survival. And so, like, according to game theory, what they should do is try as hard as possible to stay as far as possible away from one another.
Yeah, right. So the Fermi Paradox in its classic formulation assumes that civilizations are going to be like imperialists, right? Like empire model. But here we have this kind of like city-state model where they're like hiding out from each other, and so they don't contact each other. And also they want to make sure there's no evidence of their existence, so they don't engage in like large engineering projects.
And they try to stay really far away.
Yeah. So I guess like one question one could ask here is, what would Ćirković say about this sort of thing?
Yeah, is that like one of so, I mean, he considers a lot of resolutions to it. Does he consider something like this?
Yeah, I guess he does consider things of this sort, that they're like, yeah, they're hiding out. I guess this would be a kind of logistical solution, right? It's denying the economic assumptions that it would be practical, feasible, desirable for them to make their presence detectable. So, yeah, I guess he doesn't really like these kinds of explanations that appeal to like the socio-cultural facts about extraterrestrial civilizations. I mean, for instance, one of the most popular solutions to this historically is that all the aliens destroyed themselves. They discovered nuclear technology, and that all the civilizations out there self-destructed, right? That's one of the most popular explanations for the Fermi Paradox. That's a catastrophist explanation, right? It says that there's some catastrophe that wiped out all the civilizations. It was a self-destruction, right? It wasn't a gamma ray burst. It was self-imposed, but still counts as a kind of catastrophe. So he doesn't like this explanation. I think he gives this like a D or an F because it violates a philosophical principle that he makes a lot of noise about in this book. So he calls this the non-exclusivity principle. So you can think of this as the gist of it is that there's no kind of cosmic conspiracies, right? Explanations like this, ones that say all the aliens, their societies evolved in such a way that they wiped themselves out, that kind of posits a bunch of independent causes that combine in this way to achieve your desired explanatory goal. It's kind of ad hoc, right? Why think that all of them are going to evolve in the same sort of way? Like, for instance, if all the philosophers out there fail to go to the philosophy conference, and if they're all living all around the world, you shouldn't say that each and every single one of them got food poisoning. That's kind of like implausible, right? They're all living in different countries. They're all eating from different places. The fact that they all didn't show up because each and every single one got food poisoning, that's like a bad explanation. That's like lacking unification. He kind of calls this a causal parsimony principle at one point. So I think he's not going to like this dark forest thing because he's going to say, well, surely there's at least one, adventurous, maybe even irrational alien civilization out there that is not going to hide from everyone else and make its presence known, right? Why assume they're all going to be this way? That seems to violate this unification principle.
But if they're advanced enough for like interstellar travel, and if we think that it follows from like the axioms of game theory that the most rational thing to do is avoid other species, then you would think that, assuming that evolution does select for higher intelligence, maybe it doesn't. But if we assume that, it would make sense that all of the species advanced enough for interstellar travel would like recognize this as being the outcome of rational action.
Well, yeah, game theory tells us what's like rational to do when you're faced with other people who are acting, how to maximize your own self-interest given that other people are trying to do the same thing. But I mean, he can say, well, yeah, you're making a kind of assumption that's similar to the food poisoning case. You're assuming that they're all rational. Game theory tells us what's rational. It's not like descriptive, right? People act irrationally all the time. So surely, he might say, amidst these 2 billion years 9 billion years of time, surely there was one irrational alien civilization or some rogue actor, right, who was irrational. Here's the point he makes I found pretty interesting. So right now, we have more control over our environment. You and I, ordinary people, we have more control over our environment than like a 12th century aristocrat did. We can do a lot more things than they could. So he says, well, you should extrapolate this. In an advanced civilization, an ordinary person is going to have a lot more power to do things, act unilaterally, maybe make the presence of their civilization known than we can, right? Than our entire civilization can do. Like a rogue actor should be able to do this. Maybe they'll send out their own probe, right?
Interstellar travel, or even sending out a probe. That just seems like too big of a job for one.
Maybe.
I don't know. I mean, I guess I find it really plausible that evolution would select for higher intelligence. Maybe I'm wrong about that. But to me, it seems less arbitrary than just positing that everyone who didn't attend the conference got food poisoning. Because there is it seems like there would be a reason to think in this case that, everyone's behaving the same way for the same reason. Namely, that if you've evolved enough to do interstellar travel, you've evolved enough to keep your nose out of other civilizations' business.
Yeah, okay, I can see that. It is unified because there is this kind of common explanation. It's not like we're positing these sort of independent contingent factors, right? To extend the analogy with the philosophy conference, maybe all the philosophers didn't show up to the conference because the conference was canceled, and they're all rational, and they decided they didn't want to go to a conference that was canceled, and that's a unified explanation.
Yeah. All right, so let's shift gears a little bit away from the Fermi paradox, I guess it's still tangentially related to the Fermi paradox, but away from the paradox itself, because we have some stuff we want to talk about regarding abductions. So one of the notes that we got a couple times from people, they brought up that we had said that alien abduction reports was, for the most part, a uniquely American phenomenon. And we do have sources for that we can cite in the information for the episode. Some sources that do say that's true, but we didn't find a lot of hard data to support that. So we started thinking about abductions and what abduction reports could signify, what other kinds of things could count as abduction reports. And as it turns out, there's actually some interesting literature on UFO abduction experiences in religious studies work.
Yeah.
So one paper in particular called Religious Dimensions of the UFO Abductee Experience by John Whitmore, again, we'll link to that paper, talks about UFO abductions as mirroring many of the features of religious experiences, what we might think of as, or what might be called under other circumstances, religious experiences. So some of the religious themes that Whitmore argues both UFO abductions and religious experiences tend to share are some of these. Bright lights that paralyzes or blinds. Think about near-death experiences. Everyone brings up a bright light. Otherworldly superior beings in shiny clothes. They float or go through walls, both aliens and angels, demons, deceased relatives, whatever. You're taken up on a mystical journey. It feels like your soul or spirit has left your body. A lot of abduction reports involve people being judged, their life being judged in front of a panel or in front of a great leader. They're often taken to meet the supreme leader. Take me to your leader. This is, I guess, a feature of a lot of actual abduction reports. Interestingly, apparently, a lot of abductees report feeling afraid of the initial aliens that abduct them, but warm, loving feelings toward the leader of these aliens. They often return to Earth with secret knowledge or a message to give people. These messages are often moral injunctions or, deep metaphysical truths about life in the universe, something like that. Often, both abductees and people who have religious experiences experience personality changes and make big life changes, and they might report having ailments healed. So all of these are features that are common to what people identify as religious experiences and also common to abduction experiences.
A lot of these sound like near-death experiences too, right? The bright light and the floating and all that. So it seems very similar to that.
Yeah. There's some differences. So here's some features of each that aren't similar to the other. It seems like often UFO abduction experiences involve some kind of sexual assault or intensive medical probing. And in religious experiences, especially near-death experiences, often people see deceased relatives. I don't think you really get that in abduction reports. So there's some differences, but yeah, I have the same thoughts that a lot of these sound like near-death experiences, which is interesting because people don't report. It's not like they die on the operating table and come back and they're like, whoa, I was abducted.
Yeah. So is the idea that these abduction experiences are like a kind of religious experience or mystical experience? Does that seem like the idea?
Yeah, he does. He actually thinks that abduction reports are they are reports of a kind of religious experience. And I think he kind of sees all the similarities as working as a kind of like debunking of sorts to abduction, to like the reality of alien abduction. I think he thinks like what we should think is that people are not actually being abducted by aliens, but they're having some kind of experience, and they draw from either their like own personal Christian faith or like, you know, what they've absorbed through the culture to put like imagery in order to verbalize whatever kind of experience they are having.
Yeah, so one paragraph, I tweeted this paragraph the other day. So let me just read what he says. So an excellent example of an abduction is that of Betty Andreasen, whose ongoing abduction experiences have been the subject of 3 books. Andreasen herself, a devout Christian, believes that her abductors, as frightening as they are to her, are angels, servants of God. These aliens show an interest in the Bible and baptize her at the beginning of her encounters. They teach her spiritual lessons concerning the nature of the soul and resurrection and take her out of her body to cavort with them as beings of light. She reports what can only be called a mystical experience in which the aliens introduce her to a being called the One, with whom she experiences ecstatic union. So, thoughts about that, Meg? The One. You like the One, right?
So, Betty Andreasen and Plotinus are possibly the only 2 people in history to have actually successfully united with the One.
Right, so Plotinus is a Neoplatonist philosopher, right?
Yeah, Plotinus lived in the 3rd century. He was a Neoplatonist, and he was a mystic. So he's writing in the sort of mystical tradition of Neoplatonism, and he wrote about what he called the One, which a lot of people compare to Plato's form of the good, basically the source of all life and being that is. The One is beyond being. The One doesn't exist as an object. It's the source of existence. And for Plotinus, what Platonism tells us is that we need to do whatever it takes to unite with the One, to go beyond, you know, material existence, to unite with the source of being. And he called this the One, and sounds like the same thing to me.
So I guess I'd have to research this more to figure this out. But I wonder if Betty Andreasen was like reading Plotinus or something. I mean, where did she get this idea from the One from? So it says she's a devout Christian. So maybe we can see if it really is true that abduction experiences are kind of religious experience. It's no surprise that people would try to explain their experience given their own faith tradition. But where is this stuff about the One coming from?
Maybe she's an Augustinian?
I don't know.
So
some of these abductees who see their experience as being religiously inflected, they certainly don't think that there's any conflict between their religious beliefs and the existence of extraterrestrial intelligence. And in the previous episode, we talked about a lot of other philosophers and scientists who also thought that there was no conflict between the existence of other intelligent life scattered throughout the universe and their religious beliefs. So these folks think there's no conflict, but certainly some people think there is a conflict, right, Megan? So you have some thoughts about this. What do you think here? Like, why might there be a conflict? Is there really a conflict? What can we say about this?
Yeah, so there's some like, you know, prima facie stuff you can say that I guess might make it seem like, oh, well, if aliens exist, then like maybe, you know, people shouldn't think that like Christianity is true because, you know, here's when you hear a lot, there's no aliens in the Bible.
Yeah.
That is actually contestable, right?
I don't know.
There's a lot of weird things in the Bible.
Like what was it, like Ezekiel sees like a chariot in the sky, or is that Elijah? I forget.
That's Elijah.
Okay. Chariot.
Ezekiel sees the zombies.
Okay.
Yeah, but there's a lot of weird stuff in the Bible. Why think some of those things aren't extraterrestrial beings?
Yeah.
I don't know. But you hear that a lot, you know, that there's no discussion of whatever, creatures, beings, intelligent beings that aren't from Earth, that aren't on Earth. We've got this creation story in Genesis, multiple creation stories in Genesis, actually, that only talk about the creation of life on Earth, don't talk about the creation of life anywhere else. The really important, super important aspect of Christianity, the crux of it, if you will, is this idea of incarnation, that God became a human in order to enact this salvific plan for human beings. You know, this big question looms, well, would that work for extraterrestrials? Would God need to be incarnate in an extraterrestrial species to bring them the same kind of salvific plan, or not? So people have written responses to those issues before, and with other religions that don't posit a kind of human incarnation of God, you might think, well, there's even less apparent conflict between ETI and particular religion, like the other major Abrahamic religions, Islam, Judaism, do not posit incarnations of God. In fact, it's really against their religion to think that God could ever become incarnate. So you might think, well, in that case, there's even less of a conflict because we don't need God to be a particular species in order for all this stuff to work out. So maybe it's totally fine if there's other alien species. Some religions might even be like more favorable to there being ETI than they would be to there being no ETI, like for instance Scientology.
Yeah, that's like an integral part of Scientology.
That's really important. They're definitely aliens because that's who we came from, or something like that. And then I think there might be something to be said for like polytheism being able to better accommodate all different kinds of strands of intelligent life. Maybe there's some gods who are more human centric. They're like the human gods, but maybe there's some gods that are the Alpha Centaurian people's gods.
What's a nice connection to our previous episode? We did an episode on polytheism. So if you haven't listened to that yet, maybe you should go check that one out. So I know there's more to say about the Fermi Paradox. We've already spent a lot of time talking about it, but I know you still have some remaining thoughts here, Megan. So what else do you want to say about this?
Yeah, well, Ćirković talks about an implication of the Fermi Paradox, or of solutions, coming up with a solution to the Fermi Paradox, which he calls, I think, the magic mirror implication of solutions to the Fermi Paradox, which is the idea that, well, if we're going to kind of posit these sociological, or I guess it's kind of a misnomer to say anthropological, sociological explanations for why ETI hasn't made it our way yet, it sort of implies that, whatever we think is likely of them is also likely of us. So if our sociological explanation is, well, they can't get the resources together, or they just can't stop infighting long enough to, come together and make something happen, or they have, wiped out all the other civilizations with rogue technology or whatever hypothesis we favor, that implies that we think this is likely, given our nature, to maybe do the same thing.
Yeah, one explanation that Ćirković kind of favors for why we don't see any extraterrestrial life in our neighborhood is that it may have been wiped out by these sort of self-replicating deadly probes. So if that's true, that's your explanation for why we don't see any other intelligent life in the galaxy, well, we should be really scared then, because they're coming for us.
I've been scared of that since I saw Terminator, the last one we saw, the really bad one, Terminator.
Oh, I don't know. Yeah. 5, yeah.
Yeah, well, it predicts this.
Yeah. So where does this leave us? Well, I remember at one point when we were discussing this in the kitchen, Megan, you said, I'm not really sure what to make of the Fermi Paradox because it just seems like maybe we haven't looked hard enough yet.
Well, I mean, especially in the last couple of decades, we've almost totally defunded NASA and all these other kinds of like space race initiatives that we had back in the 60s when our technology wasn't as good as it is now. It just doesn't seem like we've made like so much of an effort that we can be like, gosh darn it, where are they?
Yeah, if you think about what SETI does, and this is one of Ćirković's gripes throughout the book, is that it's very, very limited what the current SETI efforts consist of. They're really just listening for radio waves. But that presumes something really, really weird about the search, because that presumes that who we're looking for is a civilization that's at like a technology similar to ours, or they're still communicating with radio waves.
Which he disputes. He finds that implausible.
Yeah, right. And one reason why is because of this temporal fact that we start off with at the beginning, namely that if there are other advanced civilizations out there in the galaxy, it's very, very likely that they're like 2 billion years old. They are much older than us. And so they probably have more advanced technology. So we really shouldn't be looking for a civilization that's at our level. We should be looking for ones that are at a more advanced level.
But we can't really do that.
There is one way he thinks we can do that. We can make a better effort to try to find these artifacts. Presumably, if there are advanced civilizations out there, we should be able to observe their existence through their use of their resources.
On the assumption that we would recognize a highly advanced technological artifact, were we looking at?
Yeah, right. Presumably they're going to exploit the energy of a star, right? So maybe we should look for these things that are called Dyson spheres, named after the physicist Freeman Dyson. It's basically like a contraption that surrounds the star to exploit it for various technological means. Or maybe we should look for, stellar waste sites. If it's an advanced civilization consuming a lot of resources, they have to dump their waste somewhere. So maybe we should look for these sorts of things. That's at least what he says. The fact that we haven't found any of these sorts of things, he thinks that makes the Fermi Paradox even more puzzling. The one important thing he does in the book, I found this really, really enlightening, is that he distinguishes between different versions of the Fermi Paradox. So we have the version where we're asking, why aren't they here now on Earth? That's what he calls the proto-Fermi Paradox. Another version, which he calls the weak Fermi Paradox, why aren't they in the solar system, or why is there no past evidence of them in the solar system? And finally, the strongest version, the version of the Fermi Paradox that's hardest to answer, is why is there no trace of any alien civilization in the galaxy at all? We're not even asking why aren't they in our neighborhood. We're just asking why is everything so quiet? Where are they?
We've observed no artifacts, no evidence of artifacts, nothing like that.
And this distinction between different versions of the Fermi Paradox is important because only some solutions will solve the strong version. Some solutions work for the weaker versions, right? But they won't work for the stronger versions. So even if you say that, well, it's too far away, or they don't like stars like our star, they don't like sun-like stars, they like red dwarf stars because they last a lot longer. Red dwarf stars, by the way, last like 6 trillion years, which is a really, really long time. Our sun only has 5 billion years left.
Is a trillion years a long time?
A trillion years compared to how long our star is going to last, right? That's a lot longer. It's like 1,000 years longer. So that's cool. So if you say, well, they don't like sun-like stars, that's why they're not here, that doesn't solve the strong version, because if they exist and they're hanging out on red dwarf stars, we should see some evidence of it. Like, where are their macro engineering projects? And like, that's the puzzle. Like, why don't we observe any of this stuff? If you accept some version of the Copernican principle, they should be out there. Where are they?
Dark forest theory is another example of something that might solve the weak version of the paradox, but you might think it doesn't solve the strong version.
Well, because they would have to go through vast efforts to conceal themselves, right? A lot of these solutions we've talked about, like the zoo hypothesis, they're not here because we're in a zoo. Well, why don't we see their macro engineering projects?
Yeah, that's compatible with them still having like observable artifacts somewhere out there in the observable universe. Yeah.
So I don't know. I mean, one final hypothesis that we haven't mentioned that I kind of like, and that is all the civilizations in the galaxy have chosen the mindless pursuit of pleasure over building large-scale projects or exploring the galaxy or sending out probes. They've chosen to plug into the experience machine. So, Megan, you're an expert on the experience machine, as everyone who has been on Twitter knows. So why don't you tell our listeners what the experience machine is?
Yeah, so I actually think we brought this up in a past podcast, but for those of you who are just now tuning in, the experience machine is a thought experiment proposed by Robert Nozick in his 1970 book, Anarchy, State, and Utopia. And it's meant to be an argument against utilitarianism or against hedonism, the idea that pleasure is the only good and pain is the only bad. But the thought experiment basically goes like this. If you were given the opportunity to enter into a virtual existence where all of your experiences would be happy, blissful, pleasurable for the rest of your life, you had to stay plugged in for your whole life. Would you choose that virtual existence where nothing's real but everything's happy over a real existence where everything's real but there's a lot of sad, a lot of tragedy, a lot of pain? Nozick assumes his audience will choose the real over the fake, thereby proving his point that we care about things besides pleasure. But we might think actually an advanced civilization might completely do away with valuing, the real or valuing non-virtual existence. They might actually think something like the experience machine is the best kind of life that one can live. Especially if that civilization is what Ćirković calls post-biological. That is, if it's merged with the machine. So that's a kind of element of the Fermi Paradox that doesn't really get a lot of airtime. Maybe advanced civilizations will be partly or fully machine-like. They've achieved the singularity. Yeah, so that changes things entirely. Maybe that changes all our expectations about what we should be looking for. So I kind of like this explanation. You can go back to the magic mirror thing we talked about earlier, that maybe if that's our solution, that that's what we should expect our society to evolve toward. And what some people might argue that's what we are evolving toward. I would argue that. Yeah, Megan would argue that. So yeah, really, really puzzling. I really liked thinking about the Fermi Paradox. I think it should be taken a little more seriously. I think there's some areas for philosophers to contribute to as well, because
What's Ćirković going to say about this experience machine solution? Well, he's going to fault it for assuming cultural uniformity. He's going to say, well, isn't it a bit of a cosmic conspiracy theory to say all the civilizations in the galaxy evolved to become transfixed with the experience machine?
You can easily see where pursuing pleasure and avoiding pain would be evolutionary beneficial.
Yeah, so I think a lot turns on that principle. And so we're talking about what makes for a good explanation, and philosophers have thought a lot about this. So I think philosophy has something to contribute to as well. We're thinking more deeply about this non-exclusivity principle that he uses a lot to sort of winnow down the acceptable solutions and what exactly would count as an acceptable explanation for this. Like philosophers, I think, can say something about that.
Yeah, I think really interrogating his, 4 or 5 assumptions?
Yeah, five assumptions. And there's various other principles he uses throughout, yeah.
Yeah, I think that would be a really good project. Because I know that I find some of those assumptions pretty dubious.
Yeah.
But that'd be a cool project to kind of think about what assumptions are less arguable.
Yeah.
So I'm really glad that our listeners kind of pushed us to look into this more. It was unexpected, but I'm really glad we did it.
I had a great time reading the book, so highly recommended.
All right, so that is all the time we have for this episode. Join us next time. We ran a Twitter poll, and it sounds like what our listeners want to hear about next time is secularism. So join us for our next episode on secularism.